My topic is optimal detector and hypothesis testing. The problem is to estimate parameters theta based on observations x. This is the data we collected or the measurement we made, which is a set of random variables. The distribution of this data can be represented by a matrix P. So this is the element in matrix P, which means the probability for the data equal to k given the theta, which is a parameter equals to j. There are two types of problems. The first one is the random parameter estimation problem. The second one is non-random parameter estimation problem. So our proposal is to find the best estimator with the minimum error. These problems can be solved by solving a convex programming problem. Now let's talk about deterministic and randomized detectors. The first one is the random parameter estimator. So it can be defined in terms of a matrix T with elements like this. So this is the probability for we made the estimation on the parameter theta, which is theta hat, given the data equal to k. This is a posterior distribution. By finding the T matrix, the random parameter problem can be solved. These are two constraints. The first one is to need to make sure that this value is non-negative and sum to 1. The second one is non-random parameter estimator. It can be treated as a special case of random parameter estimator, with all the elements in the matrix T equals to 1. Maximum likelihood estimator is the typical one. So let's talk about detection probability matrix. So why we need it? Because this matrix is introduced to characterize the performance of the randomized detector defined by matrix T, which is a posterior distribution. The definition is this. So it equals to the matrix T times matrix P, which is the distribution of the data X. So the elements in this D matrix is the probability for we estimate the parameter theta equals to I, given the true value of this parameter equals to j. So all the elements on the diagonal in this matrix is the probability for we made the right estimation. For all the other values is the error probability. The perfect D matrix is should be identity matrix. So by using this definition, we can get the detection probability and the error probability. So let's talk about optimal detector design. First, we need some constraints. The first one is the lower bound on detection probabilities, which is this one. So the second one is the upper bound on the error probabilities, which is this. one way to design the detector is the min-max detector design. So what we need to do is to minimize the maximum of the error matrix, error probabilities, subject to these two constraints I taught on the last slide. Another way to design it is to use this base detector design. First, a prior distribution for the hypothesis is needed, which is given by Q. So this is the probability for the parameter equals to I. So then we can write this matrix, then we can write the problems like this. By solving these problems, we can get the base detector. So these are some random parameter estimators. First, let's talk about the steps to get these estimators. First, we need to define the error, which is the true value of the parameter minus the estimation of the parameter based on the data we collected. And second, we need to choose the cost function, which is a function of the errors. So third, we need to solve the problems, which is to find the minimum of the risk function. It's usually defined as the expected value of the cost function. There are several cost functions can be chosen. The most widely used cost functions are quadratic loss function, absolute error loss function, and all or nothing loss function. This is the mean square error estimator, which looks like this. By finding the minimum of this value, we can get the estimator of the parameter, which is theta hat. So this is the absolute estimator. The third one is the map estimator, which means the maximum posterior. This is the all or nothing function. So by finding the minimum of this function is equivalent to find the maximum posterior. So we can find the estimator in this way. Now let's talk about multi-criterion formulation and scalarizations.